What's going on, guys? Let's look at this problem right here. Here this question is asking, determine the small signal input resistance of the circuits shown in figure 5.104. Assume all diodes are forward biased. Recall from chapter 3 that each diode behaves as a linear resistor if the voltage and current changes are small. So here they have mentioned the diode behaves as a linear resistor when in forward bias. So what does that mean is this diodes can be replaced. Each of these diodes can be replaced with a linear resistance RD. Okay, that's what we are going to do. So instead of this diode, we are going to add this resistance and then we are going to calculate Rin. Now for the first one, A, we have this diode. So if we replace that one with a resistance, this is going to be like this and like this. And here, this is, let's name this one as RD1 and this is R1. Here we have Rin. Since all of them are in series, we can directly add them. So Rin is equal to RD1 plus R1. That's the answer for the first one. Now let's look at the B part. If I replace all the diode with the resistance, this is going to be like this. And let's name this one as RD1. And let's name this one as R1. And let's name this one as RD2. And here this is Rin. Okay. Now here these two are in parallel. And this is in series. So we can add this one like Rin is equal to RD1 plus R1 and RD2 parallel. So when we have parallel, it's just a multiplication over sum. RD1 plus R1 times RD2 plus over R1 plus RD2. And if we simplify, if we take this RD plus R1 plus RD2 as a common denominator, this is going to become like RD1 R1 plus RD1 RD2 plus R1 RD2, everything divided by R1 plus RD2. Okay, so this is a B part. Now let's go ahead and do the C part. C part, let's replace all the diode with resistance. Okay, so here we have this one and let's name this one as RD. This is RD1 and this is also RD1. So RD1. Here let's call Rin. And here this is R1. And this diode also going to be replaced as a linear resistance RD2. And here we have another RD1. Okay, now we have all of them in this RD1, you can think it like RD1 like this. And then these two are in parallel. R1, RD2 parallel. And then RD1 in series altogether. Here we have RD1 and here we have RD1 again. So instead of putting RD1, we can directly add them because it's all of them are in series and these two are in parallel. So the equation is going to look like this. Rin is equal to 2RD1 because if we add these to RD1, this is going to be 2RD1 plus R1 and RD2 are parallel. So this is going to be multiplication over sum. So R1 RD2 divided by R1 plus RD2. Now if we take R1 plus RD2 as a common denominator, this is going to be like 2RD1 R1 plus 2RD1 RD2 plus R1 RD2. Okay, this is the final solution. And that's it. This is the solution for the third circuit. R in, and that's it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.